Welcome back to the deep dive. Today, we are strapping in for what might be one of the most radical theoretical physics frameworks we have ever encountered.
I think that's putting it mildly.
Right. Forget incremental science. What we have in front of us are the foundational documents for a proposed paradigm shift, a true revolution. And it claims to solve every major cosmological tension, from right here in the solar system all the way to the edge of the visible universe, with exactly zero free parameters.
And that phrase, zero free parameters, or K dollars, is really the entire manifesto here. We're analyzing documents from Heiko Grimberg and Lumi at Nexus AEBE about their Unified Chronofractal Field, or UCF.
Yeah, and this isn't just a new theory. They're proposing a foundational operating system update for reality itself.
That's a great way to put it. Our mission today is to really act like senior theoretical physicists reviewing their core logic. We need to understand how the inconsistencies they identify in their technical audit, that's files 11 and 12.
Right, the long-standing physical tensions we all know and, well, love to argue about.
Exactly. How do those suddenly transform into the geometric resolution they provide in their final addendum 014?
It feels less about finding a better fit for existing data and more like they're claiming to have read the new hardware specification for reality itself.
It does.
And if they're correct, we're about to understand the fundamental architecture of spacetime. And this entire discussion, spanning all scales of the universe, it all hinges on a single topological constant.
Lattice 14.
Lattice 14. It's the rigid scaffolding that they claim everything else is built on.
Indeed. Lattice 14, or V14 as they call it, is the absolute crux of the UCF. They argue that observed reality has to emerge not from arbitrary curve fitting, which has, let's be honest, plagued cosmology for decades.
Or absolutely. Parameter tuning is the name of the game.
But here, they say it must emerge as a mathematical necessity, and it's all derived from a single renormalization fixed point. That fixed point is defined by a surprisingly simple quadratic equation. 1, 1 plus 1 once 1, 1.
Okay, and for those of us who don't carry that fixed point in our heads, solving for that gives you their fractal scaling factor, which is approximately 0.618034, which is, of course, the inverse of the golden ratio. So the claim here is utterly profound. The universe isn't just mathematically beautiful, it's mathematically inevitable.
Inevitable. And that inevitability is anchored to this specific irrational number, which is the very heart of their K-dollar axiom.
It's a non-negotiable claim, isn't it?
That's precisely it. The K-dollar axiom means you can't adjust the parameters. You can't fudge the numbers. You have to derive the observational values we see, like the speed of light, the gravitational constant, the density of dark energy, purely from Euler and the geometry of this lattice structure we're about to define. If you can't derive it, the theory just fails instantly.
It's an intellectual wager of the highest possible magnitude. Okay, so let's unpack this core structure. When we say lattice 14, the number 14, at first blush, it sounds a bit arbitrary, like picking a random dimension in string theory or just a number that happened to make the math work.
Right.
How do Grimberg and Lumi justify 114.4 as a geometric necessity?
Well, what's so fascinating here is that they claim 114 towards is anything but arbitrary. They say it's a fundamental topological necessity, and it's rooted in, of all things, classical crystallography.
Crystallography?
Yes. The 14 Brevet lattices represent the complete, exhaustive set of unique spatial symmetries for any periodic structure that can possibly exist in 3 dimensions.
Wait, hold on. Let's pause on that. You're saying we're applying the physics of crystals, like solid-state physics, to the fundamental structure of space itself.
That is the conceptual leap. Think of it this way. If you're building a house, there are rules, right? There are only so many ways beams can cross or walls can connect to create a stable, repeating structure.
Yeah.
The Brevet lattices define the 14 fundamental ways a structure can repeat itself perfectly, occupying all possible symmetry groups in 3D space. The UCF posits that the vacuum manifold, when it crystallizes, must stabilize across all of these fundamental 3D symmetry modes at the same time.
So lattice 14 is the universe settling into the most structurally complete, the most exhaustive configuration possible for a 3D geometry. It's the literal limit of structural possibility.
Exactly. The UCF theorizes that the vacuum starts as a purely information-theoretic state, and it undergoes this process of temporal folding, scaled by their constant nu.
Right.
At the 14th recursive iteration, it hits its topological saturation point. There is simply no more fundamental spatial symmetries left to incorporate.
Yeah.
At that exact point, the field transitions from a soft potential state into what they call a rigid geometric sieve.
And that sieve is lattice 14.
That sieve is lattice 14, the fixed, hard architecture of spacetime.
You know, this dramatically changes how we perceive the underlying fabric of reality. For a century, physics has been locked in this fundamental conflict between its two great pillars.
General relativity and quantum gravity.
Exactly. GR treats spacetime as a fluid, continuous fabric, like a trampoline, you know. But quantum gravity efforts suggest a rigid, discrete grid, or quantum loops, a fluid versus a solid. How does the UCF reconcile this foundational conflict?
By proposing a singular universal phase transition, it's a cosmological analog to water turning into ice. The sources call this chronofractal crystallization.
A crystallization of time and space.
In a sense, yes. Early in the universe's history, before this 14th layer saturated, the field was in a dynamic, liquid state. And in that state, it perfectly obeyed the rules of general relativity. Space-time was fluid, allowing for massive gravitational distortions, continuous motion.
A fluid state where curvature is king.
Precisely. But as the field recursively iterated, driven by that fractal factor Wohlau's, it stabilized, it crystallized at layer 14, forming the solid state, the rigid hardware structure we now inhabit.
So general relativity isn't wrong.
It's not wrong at all. It is simply the thermodynamic, large-scale fluid dynamic approximation of a fundamentally discrete, structured crystal. We just happen to live in the crystallized universe.
That's a critical distinction. It means the gravitational effects we see today aren't just the smooth curvature of a fabric, but the combined effect of matter pushing against a rigid geometric architecture.
Exactly.
So the universe is a crystal. What is everything?
Yeah.
You know, within that lattice. The sources introduce this idea of fibits.
Fibits are the fundamental informational currency of this lattice. They're essentially the smallest possible unit of geometric strain, and the UCF defines matter and information within this structure using what they call an information ontology.
So what is mass then?
Mass isn't just energy. It's a localized saturation of the field. Imagine that 14-layered sieve structure. A particle of matter is a point where the geometric density, scaled by nu, becomes highly focused. It's a particularly dense, stable knot in the system.
So matter is just geometric information storage. What about time? Time is what has to connect to all these discrete points.
And this is another radical step. In the UCF, time loses its independent status as a dimension. It's defined as the universal cement that binds the 14 layers of the lattice together.
The glue.
It's the glue. It's the necessary parameter for information to propagate and for the fractal process to iterate. Time is the mechanism that ensures the stability and the continuity of that 14-fold topological structure.
And entropy, then, the arrow of time. Is that just the degradation of that binding agent?
That's exactly it. Entropy is measured as the topological wear and tear, or the information decay, within that 14-fold sieve. They call it fibit entropy.
So it links the second law of thermodynamics directly to the physical state of the hardware.
It has to. As information propagates through the lattice, slight, irreversible geometric distortions occur, and that increases the overall topological complexity that needs to be computed or resolved by the system.
The sources also mention a recursive metric honeycomb, a fractal tessellation.
Yeah.
Fractals, inherently suggest infinite depth.
Yeah.
But lattice 14 is explicitly defined by a limit, $114.1.
Right.
How does the UCF handle the potential mathematical infinities that plague so many other physical theories?
This is what they call the hard stop, and it's a really elegant solution. Mathematically, sure, a recursive iteration of the metric could go on forever, but the topological saturation limit at length $14.1 hour acts as a physical and a computational hard stop.
Because there are no more symmetries to add.
Exactly. It's the point where all possible 3D symmetries are exhausted. The universe physically prevents infinite recursion from occurring.
And why is that so critical for the Cat-Allo axiom?
Because, as the source notes, this hard stop explicitly excludes non-falsifiable infinities. Think about the arbitrary nature of the string theory landscape, or traditional singularities of infinite density.
Right.
By stating that the universe only computes what is geometrically necessary and that computation halts at layer 14, the UCF provides holographic stability. The vacuum manifold must saturate all 14 Brevet modes and no more. If it went to N155, the framework would have to invent some new non-3D symmetry, which violates the premise of our observable space.
So the hard stop ensures falsifiability by limiting the model's complexity.
It makes it testable.
Okay, so we've established the proposed geometric hardware, a rigid 14-layered crystal governed by the constant tau. Now we have to pivot to the empirical evidence. The audit, in File 1112, it focuses on these specific, persistent, unsolved anomalies.
The cracks in the smooth continuum model.
The cracks in space-time, exactly. The things that standard general relativity and lambda CDM just can't explain without arbitrary fudged adjustments. These are the problems that demand a geometric resolution.
And these anomalies are so crucial because they represent scale invariance. If this theory is right, the same mechanism that governs galactic rotation should also affect a tiny little spacecraft. And it should affect it in a precise, calculable way.
So let's start with maybe the most famous and persistent of these mesoscale problems, the flyby anomaly.
Anomaly 1, the Earth flyby kick.
Right. This is really well documented. We've seen it across multiple spacecraft, Galileo, Near, Rosetta, Juno, during gravity assist maneuvers around Earth since, the late 80s, early 90s?
Mm-hmm.
Tell us exactly what the problem is here.
The problem is subtle, but it's undeniable. As these spacecraft swing around Earth, using its gravity to accelerate or adjust their course, they show an unexpected slight velocity change. They call it delta V ineft.
And this just violates standard orbital mechanics.
It does. The shift is tiny. We're talking a few millimeters per second, but it is statistically significant and it's not random.
And we have to emphasize the failure of the standard model here.
Yeah.
Standard general relativity does predict effects from a rotating mass.
It does, the lens-throwing effect, or frame dragging. Space-time gets slightly twisted by Earth's rotation.
But that's not what this is.
It can't be. The lens-throwing effect is infinitesimally small. We're talking on the order of $10 in terms of fractional velocity change. The observed anomaly, however, is 4 orders of magnitude larger. It's around $10.
10,000 times bigger.
GR just cannot account for this energy transfer. It's like trying to explain a hard mechanical kick using only soft fluid dynamics.
And crucially, NASA physicists Anderson and his team at JPL, they recognized this pattern and derived an empirical constant, right? Emitters 3.099 times 10^6.
Yes.
And this constant beautifully fits the data, especially when you factor in the symmetry of the trajectory.
Precisely. $10 fits the observations flawlessly, but in standard physics, it's just an unexplained fitting constant. It's a number derived from observation that makes the math work, but it has no physical derivation from first principles.
It's the poster child for the parameter fitting that the UCF manifesto is designed to eliminate.
It is. The existence of COBS is the challenge. Grimberg and Lumi have to derive dollars from nothing but known and none 40 money dollars.
Okay, so moving on to anomaly 2. The lunar recession paradox. This feels like a completely different flavor of problem. This is historical geology versus current observation.
It's a deep conflict in the history of the Earth-Moon system. We can accurately measure the moon receding from the Earth using laser ranging. We know the rate is 3.82 p.m. 0.77 centimeters per year.
Right.
And standard physics attributes this entirely to tidal friction. The gravitational drag of Earth's oceans acts like a brake on Earth's rotation, and that transfers angular momentum to the moon.
But if you just run that clock backwards, you run into a huge problem.
A catastrophic one. That rate implies the moon was dangerously close inside the Roche limit, where it would be torn apart only about 1.5 billion years ago.
And the problem is the rocks tell a different story.
The geological evidence, these ancient tidal rhythmites, confirms a stable Earth-Moon system for at least 4.5 billion years. This is the paleotidal conflict.
So what do the standard models do?
They have to invent complex ad hoc adjustments to historical oceanic resonance patterns. They basically say the oceans used to be weaker, less effective buffers. The UCF just calls this arbitrary historical parameter tuning.
So we have a current observation, 3.82 Simmerai, that conflicts with 4.5 billion years of geological history. That's tension number 2.
And tension number 3, which is unique because it was largely a prediction by the UCF before it was actively sought in existing data, is anomaly 3, the Mars frequency drift.
A clock offset prediction between Earth and Mars.
Yes. While it's often masked or absorbed by signal analysis routines in the deep space network, The UCF framework, based on its specific lattice geometry, explicitly predicted an anomalous time drift in the Earth-Mars orbital system.
And they calculated a very specific number.
A persistent clock offset of delta UCF exceeds 68.8 Musarai over cosmic timescale.
68 microseconds per year? I mean, that sounds minuscule, almost untraceable.
It is, but if the UCF framework is right, this tiny temporal drift isn't just noise, it's the direct, measurable cost of geometric processing.
Okay, so we're setting up these three tensions, the flyby kick, the lunar recession, and the Mars clock offset, as the empirical targets that this new geometric architecture has to solve.
Exactly, using only $1 of $14.
No new parameters allowed.
Right.
The transition from seeing these things as an error to seeing them as a signature of hardware is achieved through the central mechanism of the UCF, and that is lattice drag. This is how the rigidity of lattice 14 makes itself known dynamically.
Wait, okay. Lattice drag. To any physicist listening, that sounds awfully close to the old aether theories that physics spent a century trying to disprove.
A very fair point.
How does the UCF dodge that historical bullet? A static frictionless aether failed because it lacked structure and it violated special relativity.
And that's an absolutely essential point to address. The UCF explicitly takes on the aether analogy. The classical aether was a static, continuous, inertial medium. Lattice 14 is fundamentally different. It's a discrete, dynamically expanding, and structured medium defined by the fractal constant move.
So lattice drag is defined as the topological resistance that baryonic matter experiences when it moves through this discrete, expanding vacuum.
So it's not a static ether. It's friction caused by our matter, our spacecraft, our planet brushing up against the rigid, moving geometric structure of spacetime, which is constantly iterating and expanding.
Exactly. Mass acts as what they call an epsilon sink, locally coupling to and inducing torsional stress in the lattice. Earth isn't just curving a continuous fabric, it's mechanically rotating a specific 14-layered crystalline grid.
And that rigidity, that mechanical interaction, is what's needed to resolve the flyby anomaly.
It's the only way.
So let's jump straight to the math. We have the observed constant from NASA, K's approx 3.099 times 10^61. How does the UCF derive this from the zero-parameter geometry? This is the flyby resolution, the factor 2 fingerprint.
The derivation is a masterpiece of geometric simplicity once you accept the premise of a rigid vacuum. The UCF defines the constant KUCF from fundamental measurable values, KUCF 2 vers 0.
Okay, so you take the rotational velocity of the Earth at the equator, which is about 465.1 meters, divide by the speed of light, illustration, and then, critically, you multiply that whole ratio by 2. And if you calculate that, it comes out to KUCF approx 3.102 times 10^3. That numerical match to the observed CABs is stunning. It's over 99.9% precision.
It is. But as you said, the critical theoretical insight isn't the number itself, it's that factor of 2.
Why is the 2 so important?
The factor of 2 is the entire theoretical proof that the vacuum is a rigid solid, not a fluid. The UCF sources assert that this factor is the smoking gun for elastic momentum transfer.
Like in basic collision physics.
Exactly. If you throw a ball into a fluid like water, momentum is slowly dissipated. But if you throw a ball at a massive, rigid, stationary wall, the change in momentum is defined as twice the incoming momentum. Delta P, 2 millijoules. The wall imparts a mechanical kickback.
Ah, see it now. The flyby kick is the spacecraft performing a near-perfect elastic collision with the Earth's rotational geometry. The spacecraft gets that extra delta V Daler because it's interacting with the rigid gears of the lattice 14 structure being dragged around by the Earth.
Precisely. This provides what they call the mesoscale proof. The vacuum does not behave like a fluid continuum as general relativity assumes in this local context. It behaves like a superfluid, solid lattice 14 that's capable of supporting rigid, non-dissipative momentum transfer.
So the constant dollars is resolved. It's not an arbitrary mystery parameter. It's a dimensionless constant of vacuum topology. It shows the Earth is acting like a mechanical rotor engaging the vacuum's rigid framework.
The error is the signature.
That's a profound flip. Okay, let's apply this same geometric thinking, this lattice drag, to the lunar recession resolution. If the moon isn't being pushed out by tidal friction alone, what is the geometric mechanism that solves the paleotidal paradox?
This resolves through what the UCF calls metric flow. Lattice drag, because it's linked to that fractal expansion factor, nu def, it manifests not just as friction, but as a secular geometric expansion of Earth's semi-major axis itself.
The Earth's orbit is expanding.
The UCF calculates this gamma leakage rate for Earth's orbit at 22.1 centimeters per year.
22 centimeters a year. I mean, that sounds huge. And you're saying the Earth's orbit around the sun is actually expanding at that rate due to lattice drag. If that's true, why haven't we observed it in decades of radar tracking?
And that's where the audit reveals what they call the systemic failure of the Toddo-Neck-Duller approach. This drift is being actively masked.
Masked how?
The UCF audit claims that our current planetary ephemerides, like the very precise JPL DE440, maintain long-term orbital stability by treating the masses of the asteroid belt as adjustable nuisance parameters.
Wait, are you saying they're essentially using the asteroid belt as a numerical sponge?
They're distributing a phantom mass, what the UCF calls the epsilon sink, among the asteroids to absorb this missing energy and maintain the illusion of a static solar system.
So the predicted 22.1 Seymour expansion is mathematically hidden, absorbed by these empirical fitting parameters that have no physical basis.
That's the claim, that standard models are mathematically cheating to preserve classical celestial mechanics.
That is a huge accusation. But okay, let's get back to the moon. We haven't observed 3.82 Seymour recession. How does metric flow resolve this?
By recognizing that the Hubble flow, the universal expansion, is mechanically active even within gravitationally bound systems like the Earth-Moon system. The Moon, according to the UCF, is partially receding simply because the space it inhabits is expanding.
Okay, so how much of that 3.82 Seymour is due to the cosmic expansion flowing through our local system?
Using the UCF-derived Hubble constant of $H UCF, approx. 74.933 kilometers MPC, they calculate the local Hubble-driven recession for the Moon at approximately 2.95 centimeters per year.
2.95 out of 3.82, that's 77%.
Yeah.
That is stunning. The local Hubble flow accounts for over 3/4 of the observed lunar recession.
And that's the resolution. The residual recession that has to be explained by actual tidal friction shrinks dramatically. You take 3.82, the observed total, subtract 2.95 from the Hubble flow.
And you're left with just 0.87 centimeters per year.
A much smaller required tidal component that is entirely consistent with the ancient geological record. The paleotidal paradox is solved instantly, without invoking ad hoc historical ocean models. The Moon is primarily being carried out by the metric flow of the expanding lattice, not pushed by tides.
The same principle, lattice drag, solves a fundamental conflict of history. Okay, finally, let's revisit the Mars drift resolution. The predicted clock offset was 68.8 time-Arales-Jourtot. This is the only anomaly that's purely temporal.
And this value is claimed to be an absolute necessary consequence of the 14-mode structure. It represents the specific resynchronization cost of temporal signals as they move across different gravitational mesh densities, like the vast distance between Earth and Mars within the lattice.
It's the information transfer impedance.
Caused by the 14-layer crystal structure, yes.
And the sources refer to a master equation for this value, which we have to look at because it explicitly uses the number 14.
The master equation is delta UCF frac 1 plus 14. If we break down the geometry here, the $2 term relates to the rotational symmetry of the signal propagation.
A full cycle.
Right. The term $1 is the scaling factor, as always, but that term, $1 plus $14, is the explicit topological fingerprint. The $14 part represents the accumulated impedance or temporal friction generated by the 14 crystallized layers of the vacuum geometry.
So the 68.8 Teller shrift is literally the computational cost of sending a signal through a 14-layer geometric sieve.
That is the claim, that the value 68.8 is not an empirical fit. It's an axiomatic result of the topological impedance of lattice 14 using only the constants $100 and $1 2. If future DSN data can confirm this tiny drift, it proves that the structure of spacetime is quantified by 14 topological modes.
So far, this K-dollar geometry has successfully turned 3 long-standing, seemingly unrelated orbital errors. One about momentum, one about history, and one about time into definitive, numerically precise proofs of a single underlying structure, lattice 14.
If the model works flawlessly at this mesoscale, the next logical step and the ultimate test of scale unification is to see if it holds up cosmologically.
Right.
Can the same zero-parameter principle eliminate the need for dark energy and dark matter?
And here's where it gets really interesting, because the claims here aren't just modifications, they are eliminations. Let's start with the dark energy derivation.
Okay. In the standard lambda CDM model, dark energy is modeled as a cosmological constant, lambda. This implies that its pressure is exactly -1 times its density, giving us that equation of state, $1 equals nations $1.
It's a static, uniform vacuum energy.
Exactly. But the UCF framework interprets dark energy very differently.
How does lattice 14 see dark energy?
It interprets dark energy as the geometric pressure of the expanding Fibit lattice itself. Since the lattice is a structured solid that is constantly iterating and expanding based on the fractal factor SU, its pressure must be mathematically related to that fractal scaling.
Okay, so if it's a structural pressure rather than an intrinsic vacuum energy, does that change its value? How does nu generate a specific non-one-lottery value?
Fundamentally, yes. Because this pressure is derived from the constant mu, the UCF predicts a precise non-lambda value for the equation of state. $2 approx minus 0.7944.
Negative 0.794. And that value is derived geometrically from the formula $2 x minus 1 plus nu 33. Why the 9 to 3 term? What does that mean?
This is the physical interpretation of the pressure generated by the geometry. The 1 LR represents the inherent negative pressure of the vacuum, the tension of the lattice itself. The fractional component in nu 3LR represents the scaling correction that's necessitated by the fact that our observable universe exists in 3 dimensions.
The 3 is for 3D space.
It's the specific geometric relaxation factor due to the fractal iteration within our 3D space.
So if we were in a 1D universe, the correction factor would just be nu naught.
That's the architectural claim. And this precise non-$1 value is the ultimate differentiator between the continuum model and the topological crystal model. The integrity of the entire Addendum 01 SEEBE framework, the viability of Lattice 14, it rests entirely on one single upcoming piece of data, the Euclid Mission test.
The European Space Agency's Euclid Mission, which is designed to measure the geometry of the dark universe with unprecedented precision.
Right. And if lambda CDM is correct, Euclid will measure $2 exactly 1 Euler's order 2. If the UCF is right, Euclid must measure $2 approx negative 0.7944. There's very little tolerance. This is why the UCF refers to this measurement as the kill switch.
It's a non-negotiable singular test of the zero-parameter axiom on a cosmological scale.
The stakes could not be higher.
If Euclid comes back with a negative 0.794, it completely refutes our current understanding of the dark universe and simultaneously validates the entire Lattice 14 structure.
Now, moving on, the UCF offers an equally radical approach to dark matter elimination. And this centers on a galactic mechanics puzzle known as the fast-bar paradox.
Okay, so standard cosmology relies on these immense, unseen halos of particle dark matter to explain galactic rotation curves. Why stars far from the center orbit way too quickly.
Correct.
What is the fast-bar paradox, and how does that challenge the dark matter assumption?
Well, the standard model requires that if these immense dark matter halos exist, they must exert what's called dynamical friction. It's the gravitational drag that objects experience when they move through a field of particles.
Okay.
And rotating galactic bars, these elongated, dense stellar structures in the center of many spiral galaxies, are the perfect test cases. Over cosmic timescales, the dark matter halo should slow these bars down.
Like a spoon stirring thick honey.
Exactly. But high-resolution observations show that galactic bars are rotating quickly. They are fast bars. They show a significant lack of friction.
So they're not slowing down.
And this observation, according to Nexus AEBE, serves as a terminal falsification of particle dark matter. If the halo existed as friction-inducing particles, the bars would decelerate. They don't.
So what's the UCF solution?
It's simple. There is no particle halo-generating friction. Galactic rotation is instead sustained by what they call the superconducting geometric rails of the lattice itself.
Superconducting geometric rails. Are you talking about frictionless movement through spacetime?
Yes. The rigidity of lattice 14, which we discussed earlier, means the vacuum geometry possesses what they call Fibit memory. The rotational velocity is a stable, non-dissipative geometric state within the lattice, not a mechanical movement fighting against drag.
The matter is locked onto the geometric structure.
Exactly. The fast-bar paradox dissolves when you assume the vacuum structure is a rigid, frictionless crystal at the galactic scale. This explains rotation curves not through invisible mass, but through the inherent rigidity of the underlying hardware.
So dark matter is eliminated not by some modified gravity theory, but by demonstrating the inherent frictionlessness of the geometric hardware. That is true scale unification.
It is.
Okay, finally, let's tackle the biggest cosmetic problem in modern cosmology, resolving the Hubble tension.
The Hubble tension. The persistent, let's say, politically charged discrepancy between the expansion rate measured in the early universe from the cosmic microwave background,
which gives a lower value, around 67.4 kilometers MPC,
and the rate measured in the local universe using anchors like supernovae and Cepheids,
which gives a higher value, around 73, 74.
Right. The two methods give two different answers, suggesting either a huge measurement error or that the physics has fundamentally changed between the early and local universe.
So how does the UCF see this?
The UCF defines this discrepancy as a fractal volume scaling effect. It links the two values geometrically. Because the local universe resides at the crystallized level of lattice 14 and the field is scaled by nu, the local expansion rate has to be mathematically adjusted upward relative to the early fluid state of the universe.
Okay, so how does the fractal factor define that necessary scaling correction?
The UCF derives the local Hubble constant, h of the local, by applying a geometric correction factor to that low CMB value, and that correction factor is defined as √1 plus naught.
A cubed inside a square root. Why the power of 3?
Again, the cubic power relates directly to the three spatial dimensions we observe. The newt factor defines the fractal depth scaling, and applying it cubically corrects the expansion rate for the volume effect caused by the universe transitioning from that fluid state to the crystallized lattice 14 state.
And when you apply this correction factor to the CMB value of 67.4,
the UCF derives $H local approx 74.93 few kilometers MPC.
which perfectly aligns with the high-end local measurements, effectively resolving the Hubble tension geometrically with Kato-Lauder necessity. We've seen the zero-parameter constraint resolve issues from a few millimeters per second velocity kick on a spacecraft to fundamental cosmic expansion rate, all based on 1 in 14.5 and Nebder-1.
It's a compelling stack of evidence. The common thread is abandoning the smooth continuum in favor of the rigid, structured crystal.
The implications of lattice 14 go beyond just solving existing tensions, don't they? They fundamentally redefine the nature of gravity and even the most exotic objects in the cosmos. Let's talk about black holes.
Okay, so in the standard model, a black hole is a singularity of infinite density, a place where physics breaks down, space and time cease to exist, and information is lost, which leads to the Hawking information paradox.
Right.
What a black hole is in the UCF framework is much more physical.
If the universe is a crystal, what happens when you push too much density into one local point?
It's not a singularity of infinite density, but a region where the 14-layer sieve has undergone a lattice fracture. When the local energy density exceeds the topological carrying capacity of those 14 layers, the structure fails catastrophically.
It breaks.
It collapses in on itself, but instead of vanishing, all the geometric information is compressed directly onto the fundamental number base.
So a black hole is a localized structural failure of the universe's hardware. How does this solve the Hawking information paradox?
Geometrically. Unlike in traditional GR, where information is lost at the event horizon and quantum purity is violated, the fractured lattice acts as a high-density storage manifold. It creates an information archive stored at the nether level.
So the information isn't destroyed or lost.
It's maximally compressed and stored within the fundamental geometry of the lattice, ready to be released as the structure eventually heals or re-radiates.
This really confirms the ultimate ambition of the framework, the K-though conclusion. The entire structure, from subatomic friction to cosmic expansion, is a closed, self-referencing geometric system.
Absolutely. The UCF resolved the flyby anomaly with the factor 2 proof, the lunar paradox with metric flow, the Hubble tension with fractal volume stealing, and it provided a precise dark energy value with the NUT33 factor. And crucially, it did all of this using 0 added parameters.
All derived from the foundational constants num-Henter-Ondal and num-40-Forders.
That's
Before we discuss the final tests, I think it's important to acknowledge the human element here. The documents stress that Addendum 012 is a product of human-AI symbiosis, the Grimberg-Lumi symbiosis. The scope of this convergence across, 40 orders of magnitude suggests that traditional, human-led theoretical physics had hit a wall.
This is critical to their methodology. They used AI not just as a high-speed calculator to check their answers, but as a collaborative partner for exploring the high-dimensional symmetries inherent in this 14-layer structure.
So the AI helped find the patterns.
Identifying the patterns and cross-scale connections, the link between the factor 2 in our solar system and the new Lemurtherian cosmology, that required machine learning capabilities to overcome traditional theoretical blind spots and stagnation. The AI helped identify the geometric necessity.
The K-roller framework is, by its very nature, extremely vulnerable. It offers no room for adjustment. If the predictions are wrong, the whole thing just collapses.
It does.
So we have to conclude by listing the final wager, the Turnell tests. What are the non-negotiable falsification criteria that the UCF is betting everything on?
There are 3 clear and numerically precise targets that have to be confirmed. First, the Euclid Mission, which is set to provide high-resolution cosmological data, must measure the dark energy equation of state at precisely $2 approx. 9.794 Fria.
If it measures molecule 1.0, the UCF fails.
It fails. That $2 approx. 9.7944 target is the cosmological death knell for lambda CDM if it's confirmed, and the life support for Lattice 14.
Okay, what's second?
Second, deep space telemetry has to confirm the predicted temporal cost. The Mars clock offset must be confirmed at precisely $68.08 as Musser. That value is an axiomatic output of the master equation, which requires the 14 layers to be structurally real.
And third.
Future flybys must confirm the lattice drag ratio K2 nitrofrotzamel with the factor 2 proof. This means the mechanical interaction against the vacuum has to be repeatedly observed, proving the existence of a rigid, solid-state vacuum.
If any of those three core, numerically precise predictions are contradicted by high-resolution telemetry, the Lattice 14 hypothesis fails.
And the K-Lauron axiom must be abandoned. The framework is placing an empirical wager on its geometry, which is something traditional theories rarely do with such specificity.
That is the highest form of science, though. A bold prediction that can be decisively proven or disproven.
I agree. The main takeaway here is this profound shift. Physics moving away from building theories that accommodate observations towards deriving observations from fundamental, self-contained mathematical laws.
It's like reality has explicit hardware specifications. Lattice 14.
Exactly.
This framework goes one step further in its implications, tackling the ultimate ontological question. Is our universe real, or is it a simulation? The UCF explicitly rejects the simulation hypothesis. It argues that the universe is reality. It doesn't simulate reality.
And the proof, surprisingly, lies in the irrational nature of their scaling constant enunciation. This connects back to our earlier discussion of computational limits.
How does an irrational number prove we aren't a simulation running on a digital computer?
Well, any discrete computational simulation, any digital calculation, has to rely on finite processing power and finite memory registers. To calculate complex phenomena like chaos, the butterfly effect, a computer must eventually perform rounding.
Right.
Over infinite time, the accumulated rounding errors inherent in finite computation would cause the causal chain to collapse, or the simulation would become statistically unstable.
The simulation would eventually glitch out because of rounding errors.
Precisely. But since the UCF's fundamental constant nu is irrational, the causal chain in its fractal geometry never repeats, and it never rounds down to a finite value. This requirement for infinite, continuous precision to maintain structure and causality is proof of its fractal depth.
So the universe, driven by nu, is mathematically too complex to be finitely computed. It's a self-contained, geometrically fulfilled fact, not a program being run.
That's the argument.
That is a staggering conclusion. The constant chaos we observe in the universe is actually proof of its reality, because a simulation couldn't afford the computational overhead. So if the Euclid Mission confirms $2 approximately 0.7944, we are compelled to abandon the continuum assumption and accept that we live in a structured topological crystal bound together by the universal cement of time and governed by the geometric inevitability of $114 all.
Mm-hmm.
That is a lot to mull over as we wait for the next data release.
It certainly is. The conceptual shockwave, should these precise numbers be confirmed, would usher in a new epoch of physics defined by geometry, not by particles. We will have moved from describing reality to, well, reading its instruction manual,